Hello everyone, wishing you all a very good morning. I hope I'm audible and visible to all of you. You can hear me? See me? Okay. Chalo. Today's class, what we are going to do is we are going to do something very interesting and something very, what should I say, different. Now, what we are going to discuss today is basically meant for JEE Advanced only. The chances of this thing coming in JEE Mains is practically zero. It will never come probably. Anyways, so pay attention to the class, and if you have any doubts, you can definitely ask them. You can watch the video again whenever you feel like. You might find something. It's not difficult. Nothing is difficult in life unless and until you decide it to be difficult. Something is different. So we are going to do this different thing, and that's why I put a star on it. Basically meant for JEE Advanced and JEE Advanced only. It will never come in mains. Okay. Now, what is that thing that we are going to discuss? We have already discussed what are conservative forces. Okay, great. Now we are going to find out how do you know whether a force is conservative or not. So the heading would be how to find out a force is conservative force or not. So test for conservative forces. What is the test for conservative forces? How you can find out whether a force is conservative or not. Now you already know that if you know that the force is gravity, it is conservative. So let us first put whatever we know onto the paper. That the first thing I know is number one, gravity or gravitational force and spring force are always conservative. You don't have to do any test on these forces, they are always conservative. Take my word. One more force is always conservative, and that thing is any constant force. Any force that is constant, does not change its magnitude or that does not change its direction, both together. Should not change its magnitude, should not change its direction. That force is always a conservative force. Example, a very simple example, if I write this force F vector, but if I write it in vector, I write the most general form. If I write the force as 3I minus 4J plus 3K, as you can see, if you look at the exponents of I, J, and K, they are all numbers, they are all constant. This is a conservative force. You don't have to do any tests, it is a conservative force. But what about any force, any other force that you get? How do you want to, or how will you find out whether it is conservative or not? And why do you want to find out? Two questions are there. Why you want to find out, and how you can find it out. Now why, we'll answer that why later on. Let us first see how do we find out whether a force is conservative or not. What is the test? What is the test for a conservative force? Let us say, let us take as an example the most general force that I can think of, Fxi hat plus Fyj hat plus Fzk hat. This is the most general force that I can see. How will I find out whether this force is conservative or not? We already know if this is gravity, conservative. If this is spring force, conservative. If it is a constant force, it is conservative. That means If fx, fy, and fz are all constants, all should be constant. Then it's a conservative force, not a problem. But what if? What if all are not constants? How do I find out whether a force is conservative or not? And I will not get into how this formula is derived, because that is pure maths and this is not a class, and how this formula is derived is out of the reach of this class. Probably when you study MSc in physics, you will derive this formula. The formula says that if I have to find out if this force is conservative or not, three conditions should be met. Three conditions should be met. What are those three conditions? Del fx by del y should be equal to del fy by del x. That is condition number one. I don't know whether you know what is the meaning of this del. Doesn't matter. You will come to know. The second condition would be del of fx by del of z. Del fx by del z will be equal to del of fz by del of x. Del fz by del x. Now I've given you two conditions. Can you now tell me what would be the third condition? Common sense. This has got nothing to do with physics or maths. First condition is del fx by del y is del fy by del x. Look at the pattern. Second condition is del fx by del z is equal to del fz by del x. What would be the third condition? I don't see anyone in the online class, so everyone in the offline class, I hope you have a mic which is lying somewhere. Can you tell me what would be the third condition? Those three conditions, if they are met together, all three conditions must be valid at the same time. Then I can say the force is conservative. I've given you the two conditions, putting some common sense. Can you tell me what would be the third condition? Anyone in the class? I hope I'm audible and visible to all of you. Look at the pattern. Tell me what would be the third condition. No one? I see the mark getting passed.
Sir,
Yes, beta. What's your name?
Anok, sir.
Alok? Anup?
Anok.
Anok? Acha, Hanak. Oh, sorry. That's how you pronounce it. Okay, Hanak, tell me, what will be the third condition?
Del y by del z equals to
Yes.
del fy by del fz.
Yeah, that is correct, Hanak. That is correct. Del of fz, I call it z, by del of y should be equal to del of fy by del of z. That is the third condition. Very correct. Now, if all these three conditions are fulfilled simultaneously, then this force F is conservative in nature. Then this force is conservative in nature. Now, the next question arises. The most obvious question is, what is this del fx by del y, or what is this del y by del x, del fy by del x? Now, we already know a term known as dy by dx. We already know a term known as dy by dx. Can anyone tell me what is meant by dy by dx? We have done it in much detail. What is meant by dy by dx? What is meant by dy by dx? No one knows?
differentiable of y with respect to x.
Great. It is known as derivative of, I'll just using a different form of the same word, derivative of y with respect to x. Now, what I did not tell you when we were dealing with del y by del x is that I have to put something else also with this. Just did not want to confuse you. As I always keep on telling you, the way I teach physics is on a need to know basis. I'll only tell you what you need to know at that point. Maybe after some time, I'll tell you something else that is known as need to know basis. Now, what I did not tell you when I was telling you dy by dx, it is not as the complete or full derivative. It is the complete or full derivative, full derivative of y with respect to x. Now, once I've used this term full derivative, then that gives rise to a possibility that there could be some other thing that is not the full derivative. And what that thing is, which is not the full derivative, that thing which is not the full derivative is known as partial derivative. So now we have another term coming up, del fy, I'm not writing fy, del y by del x. Now instead of d, I've used del, Greek word, Greek alphabet. Del y by del x means it is still the derivative of, y with respect to x. Nothing changes there. But again, I have to put that prefix, and the prefix has changed. It is now known as the partial derivative. It is now known as the partial derivative. Oops, wrong color. It is now known as the partial derivative. This gentleman is the full or the complete derivative. Now, this gentleman is the partial derivative. Both are derivatives. Nothing changes on that front. Okay, good. What's the difference? That is the next question. Sir, what is the difference between these two? Let us try to find out. And again, this is a class more on maths rather than physics, because physics has got nothing to do with all this. But without maths, just can't do physics. Okay, let us take an example. I have a function. Oops, wrong color. Do you see this? Okay. I have a function t. I have a function t, which is x squared plus y squared. So it is a function of x and y both. Because if I don't bring both things, you will not be able to understand what is the difference. Now, t is a function of x and y both. What do I do here is I find dt by dx. Now I give you a minute to do it. What is dt by dx? Derivative of t with respect to x. That will take you back to the class on derivatives. What is dt by dx? Here in this case, can anyone tell me? What is dt by dx? Okay, I'll tell you. So dt by dx, 2x plus 0. Okay, let me tell you what it is. We never did functions like this in derivatives. So I'll tell you how do I differentiate this. So first thing I do is find the derivative of x squared with respect to x. It is very simple. The derivative of x squared with respect to x is 2x. No questions asked, no answers given. Now remember here, this gentleman y is not a constant. Someone said that it is 0. Its derivative is 0. No, its derivative is not 0 because this y is not a constant. If this y is not a constant and I have to find the derivative of this y square with respect to x, Now, how do I find the derivative of this y square with respect to x is that I do it in this way, plus is already there. I differentiate y, so it is 2y. And then I differentiate y with respect to x. This is known as the chain rule of derivative. I did not discuss this chain rule of derivative because it was not required in physics. This is known as the chain rule. So how did I differentiate y square with respect to x? I differentiated y square with respect to y, that is 2y, and then I differentiated y with respect to x. So the answer is this, and this is the answer that you should have got. The complete derivative of t with respect to x is this thing. Now, if you have understood, I will change the question and I'll put it like this. Can you now tell me what is dt by dy? It's not rocket science.
Sir,
Yes.
2x dx by dy.
Okay, I'll write it. 2x dx by dy. Great.
Plus 2y.
Great. See, since I did not tell you all these things at a point where probably it would have been difficult for you to understand, now since you have grown up, you can understand how it comes, and my task becomes simpler. Even if I would have told you at that point in time, I would have still need to tell you right now. So I save some time over there. That is absolutely correct, beta. dt by dy is 2x dx by dy. So I differentiate x square with respect to x, that is 2x. Then I differentiate x with respect to y, dx by dy. And then I did do the same thing with y square, but I only need to differentiate y square with respect to y. So that is 2y. So that is your answer. Did we get all these 2 points, everyone? Can I have some raised hands? Okay. Now, that's complete or full derivative. Now, how is partial derivative different from this? The partial derivative, when you are differentiating something with respect to partially, what it means is the first answer, the answer to the first one, dt by dx, would be what someone said in the very first case. Who was that someone who gave me the answer that dt by dx would be 2x plus 0? Who gave me that answer?
Sai Shraddha.
Yes, beta, what's your name?
Sai Shraddha.
Sai, beta. Yes, Sai. You gave me the answer that derivative of t with respect to x. That was the answer that you gave me. That derivative of t with respect to x is 2x plus 0. Now you gave the same answer. You gave the right answer, but the question was not correct from my part. That is not the derivative of t with respect to x. This is the derivative of partial derivative of t with respect to x. This is the partial derivative of t with respect to x. So basically what it means is, when I am differentiating something partially with respect to x, when I am differentiating something partially with respect to x, I only need to find the derivative of those things which are with x, which are in x. Rest everything is a constant. So in the expression t is equal to x square plus y square, if I am differentiating it with respect to x, only I need to differentiate the x wala points. The other things, y, z, m, n, o, p, whatever, they're all treated as constants. So that is the difference between complete derivative and partial derivative. If you have understood this, then you should be able to tell me what would be del t by del y.
0 plus 2y.
I don't have to say 0, so I just write 2y. Got the answer? 2i. I don't need to differentiate x squared because its derivative is going to come to 0, because that x squared will be now treated as a constant. This is the difference between complete derivative and partial derivatives. I'll give you a minute to write it, and then we will put whatever we have learned into use and see how it helps us in finding out whether a force is conservative or not. Okay, I think most of you have done this. Let us move. Now let us take an example and find out whether this force, whether a given force is conservative or not, and how would you find it out. Let us take the example of this force. Now you would say, sir, we know the answer for this one, but still let us see how that force becomes conservative. Now, even without doing any test, don't have to do any test here. You can straight away say that this force is conservative or not. Is this conservative or is it non-conservative? Anyone? Is it conservative or is it non-conservative? Do I need to do a test, or should I, or can I say that without doing any test? No one knows the answer? This force is a constant force, so it has to be conservative. This is a constant force. And we have already discussed that if a force is constant, it has to be conservative. But again, even if you don't know it, how do you check it? Now, if you look at this, 3, this is fx, minus 4 is fy, and 5 is fz. I will do the first test. I will find out del of fx by del of y. Partial derivative of x component with respect to y. So I have to find out the partial derivative of 3. Partial derivative of 3 with respect to y. What is the partial derivative of 3 with respect to y? It is 0. I have to find the partial derivative of 3 with respect to y. 3 is a constant. Partial derivative has to be 0. Did we get this? Yes or no? Then what I need to do is I need to find out the partial, oops, wrong color. Then wrong color. Then I need to find out the partial derivative of y with respect to x. Now this fy is minus 4. If I find the partial derivative of minus 4 with respect to x, my answer would be 0. 0 is definitely equal to 0. So first condition is definitely met. Do we get this? Yes or no? Now, if you repeat the test, step number 2, step number 3, find the partial derivative of x, fx with respect to z, find the partial derivative of fz with respect to fx, x, everything will turn out to be 0 because everything is a constant. So all the 3 conditions would be met, all derivatives, fx with respect to y, fy with respect to x, fx with respect to z, fz with respect to x, fy with respect to z, and fz with respect to x will turn out to be 0, and therefore this force becomes a constant force and a conservative one. Do we understand this? Can I have some raised hands that we have understood this? That this force is a conservative force We don't have to think about anything else here. Okay, done. Let me give you example of another and ask you whether it is conservative or not. I have written this force. F force is x square I minus 2y j plus 3 times k. Can you tell me whether this force is conservative or not? Whether this force is conservative or not, your time starts now. X square I minus 2yj plus 3k, whether this force is conservative or not. Do I have any answer from anyone?
Non-conservative, sir.
Non-conservative. Who said this answer? Who gave this answer?
Sai Shraddha.
Sai. This force is non-conservative. Okay, let me check. How do I check? I have nothing in my hand to check, but I have just 3 conditions. So first I have to find del of fx with respect to del of y. How much is this, beta?
2x.
Yes, beta?
2x.
Del of fx with respect to y. Derivative of x squared with respect to y. Partial derivative of x squared with respect to y, and your answer would be 0. Yes or no? I am differentiating,
How,
I
sir?
am partially differentiating x squared with y. X is a constant, only y is variable, so it has to be 0. Yes or no? Do we understand this?
Sir, can you explain it again?
This is the partial derivative of x squared with y. In partial derivative, we only differentiate y with respect to y, or x with respect to x. This is x squared with respect to y. Answer has to be 0. We have just seen the examples in the top, right? Then I find out the partial derivative of f of y with respect to x. So I have to differentiate. I have to differentiate minus 2y with respect to x. What would be the answer? What would be the derivative of minus 2y with respect to x? I am talking about partial
0.
derivative. 0. Well done. So first condition is met. Do we all agree? Let us now move on to the second condition. Partial derivative of fx with respect to z. This is my x, gentlemen. Oops, wrong color. I have to find the partial derivative of this, gentleman. Tick, 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 tick. With respect to z, what would be the answer?
2x, sir.
Again, wrong answer. Answer is still 0.
0.
Okay, not a problem. We'll do mistakes. Mistakes are a part of life. Then I'll have to find out the partial derivative of this plus 3. 3. Let us find it out. partial derivative of fz with respect to x.
Zero.
I need to put it here. Yes, this is definitely 0. 0 is equal to 0. Second condition is met. Let us now move on to the third condition. Del of fz with respect to del of y. fz is here. Tung, tung, tung. Tuk, 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 tuk. It comes here. What is the answer? 0. Yes, 0 is the answer. Del of fy with respect to del of z. This has to come here. Ting, 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 ting. What is the answer?
0.
All the conditions have been met.
Total zeros.
All are zeros. Now you will have an idea. You may not have to do it every time. You see, what is the shortcut if I say shortcut? If with I, you only have x wale terms. If with j, you only have y wale terms. And if with k, you only have k wale terms, yeah, constant. If you have such force like this, it will always be a conservative force. You don't have to do this once you understand this. You only have to do this when it looks somewhat different. Else, if it is a simple force like this, you can use your common sense. Every time you don't have to do this. Do you understand how we have achieved this? If you only see xk terms or constant terms with I, if you only see yk terms and constant terms with j, if you only see zk terms and constant terms with k, it has to be a conservative force. Do we understand this, or it has gone bye bye? Can I have some reason that we have understood this? Don't have to do all this. Once you understand this, and that is what I say, smart hard work and hard work put together. The more the number of questions you see, the better you have an idea of how you can do them quickly. As I always tell you, JEE, whether it's main or advanced, they are more based on your calculating abilities. JEE advanced, maybe 3 or 4 questions you will find that will test your understanding. Most of them are basically based on your, what should I say, speech. Let me now give you an example and let us see if anyone, now this is the most difficult force that can ever come in a JEE exam. It will never come. It will never ever come. This is too beyond JEE. But now I'm giving you this. Can you tell me whether this is a conservative force or not? Looking at the force without wasting time, is this a conservative force or not? Is it a conservative or is it a non-conservative? 2x plus 3x square plus 2i minus.
Sir,
But
it's A cap.
it's
A cap. Oh, the
oh yes, yes, yes,
Y cube plus.
yes, 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 yes. Got it, got it. Mistake in writing. So is it conservative or is it non-conservative? If you are taking this much time, that means we have not understood the concept. And the answer is, what is the answer? This has to be a conservative force. Yes or no? Why it should be a conservative force? Because if when I look at the terms with I, they only have x or a constant. If I differentiate these terms with respect to z or with respect to y, I always get 0. When I look at the terms with j, I only see terms of y. If I differentiate these with respect to x or z, my answer would be 0. If I look at the terms with k, I only see z and 5 constants or zk terms. Their derivative with respect to x or y will be 0. So all derivatives will come 0. So this has to be a conservative force. Do we understand this or it has gone above our heads? I see some hands being raised from the back. Back girls. What about the front ones? Left hand side, right hand side, center. Have you understood this? How I have done it without doing any calculations? I've understood the concept and now I'm just applying it and I'm doing it faster. So this is a conservative force. So this is the answer to the first question. How do we find out whether a force is conservative or not? How do I find out whether a force is conservative or not? The next question is, if I find out, what is the advantage of it? Why I want to find out? Now, I hope we are okay and we are ready with the fact and we appreciate the fact that we now know whether a force is conservative or not. Now, what is the advantage of being a conservative force? Now we think about what we have studied in conservative force. And the main point that we must remember here, that work done by conservative force, C means conservative, does not depend on path. And that is the most important thing that comes out of this discussion. We already know it. Work done by this conservative force does not depend on path. What advantage do I have? Now see, that is where JEE becomes a bit different. I will not call it difficult. Once you have understood the concept, they will not ask a question straight away on the concept. No, they will not ask. They will ask you in a different way. How they might ask you. So I'll just try to give you an example of how a question may come. It may not be the same way that the question comes, but if you have understood the concept, that's how you apply concept and get an answer out of nothing. For example, a question comes like this. This is x, this is y axis, and a particle is here. This coordinate, this is 1, 1. This is point B. The coordinates are 2, 2. I have written 1 here. 2, 2. Now, one force is going to take this particle along 3 different paths. This is path number 1. This is path number 2. And this is path number 3. The black one is path number 3. Now, I'm going to tell you the force. The force is F is equal to two x I minus 3j. Now this force is displacing a particle from A to B in three different paths. Now, if I make a multiple choice question out of this, I'll give you these choices probably, and this could be a multiple choice question. So I would give you options like that. Work done in path 1 is this, work done in part 2 is this, work done in part 3 is this, work done in all the paths is same, work done in all the paths is different. So I'll give you probably these 4 or 5 choices. What is the work done in path 1, what is the work done in part 2, what is the work done in part 3. Three options are here. Work done in all the paths is same, work done in all the paths are different. So you have now 5 choices. What would be your answers? And I'm not calculated the work done, that's why I don't know how much work is done. So probably you have 3 different work done. For part 1 you have some answer, for part 2 you have some answer, for part 3 you have some answer, then the fourth option is all work done would be same, then the fifth is all work done would be different. This is a multiple choice question, so you may have more than one answers to go with it. How will you do it? Now the first thing that you would check here, what is the first thing that you would check? Anyone? What is the first thing that you would check? Or the first thing that you see in this question? What is the first thing that you notice in this question? No one knows? Okay, no one knows, then I must tell you. The first thing that we notice in this question is that this force is a conservative force. Yes or no? Is this force conservative or not? Do I have some raised hand? Do we understand that this force is conservative? Okay, this force is conservative. Now, once this force is conservative, one of the options already goes away. Work done in all the paths is different. That option goes away because now I have one right answer, that work done in all the paths is same. So now I don't have to find out work done in first path, work done in second part, work done in some third part. I just need to find out one work. And that one work will be same for all. Now, what is the advantage of this conservative force? This conservative force, the work done by this conservative force does not depend on path. Now, as soon as I understand this, I will just simply put the formula that the work done by this force will be the integral of fx dx plus fy dy. I don't have to look for the path. It's as simple as that. Why should I look for the path? There is no way I have to look for the path. I just need to put this formula, get the answer, and stay happy. Whether it is going from path 1, or it is going from part 2, or it is going from part 3, work done has to be same. So I just find the integral. Can you tell me what is the work done by this force? It could be in part 1, it could be in part 2, it could be in part 3. I hope you remember how to find out the work done by a variable force. I hope we remember how to find out the work done by a variable force. So what I do, I put the values. 2x goes here. Minus 3 goes here. and this is definitely 0. So it basically cuts. So what do I have? I have work done is integral of 2x dx. From where to where x is varying? X is varying from 1. This is the initial point, and the final point is 2. So x is varying from 1 to 2. So I put the limits from 1 to 2. Then I have minus 3. So I just put minus 3 dy ka integral. This is the green integral. From where to where is y varying? As we can see, y also varies from 1 to 2.
Sir.
So I just put the limits from 1 to 2.
Sir,
Yes.
sir, your slide is paused.
Oh, sorry. Do you see it now? So what I have done is I have just put the values. I have just put the values of fx here, and I have integrated it. And I put the integral sign. I hope you understand this.
Sir, explain this again, sir.
I put the values of fx, which is 2x, and I put the value of fy, which is minus 3, and I put it in the integral, nothing else. Clear? You can see fx is 2x and fy is minus 3. So I've just put the values, and I have put the values of limit. X is varying from 1 to 2, and y is varying from 1 to 2. Both the limits are same because x and y, they both are varying from 1 to 2. Do we understand this now? Now you can easily calculate the integral. I will not do the integral. You know how to calculate it. If you don't know, then go back to the class and have a look at how to solve this integral. This is the way that you can solve any problem that comes in conservative force. If you understand that the force is conservative, you don't have to look for paths. You can just
Excuse me, sir.
calculate the integral. Yes, beta.
So once can you please repeat again, sir?
What do you want me to repeat? What you have not understood?
Yep.
What you have not understood? You have not understood that value of fx is 2x. Have you understood that, beta?
Yes, sir.
I put that value. Have you not understood the value of fy is minus 3? I put the value of fy as minus 3, and then I put the integration limits. What is there that you have not understood? Do you remember this formula or not? Remember this formula or not?
Yes, sir.
But I've just put the values. There's nothing else. Value of fx is 2x. I put the value. The value of fy is minus 3. I put that value. Nothing else. What is there that I have done differently? What is there that you don't understand?
Understood, sir.
What is the point that you don't understand, beta? Tell me. Yes?
Understood, sir.
Yes? I'm not able to hear you, beta. What is there?
Now I understood, sir.
Okay. Value of fx is 2x. I put it. Value of fy is minus 3. I have put it. And I will just need to find the integral now. Value of x. X is varying from a to b, 1 to 2. Y is varying from a to b, again 1 to 2. So I put the values. Now, I hope you can calculate the integral and find the answers. Can I have some raised hand that we have understood this? Everyone? I only see 4 or 5 raised hands. What about the others? If you don't understand, please ask.
Sir, answer is -2.
Well done. You got the answer. Well done. I am not going to check it. I am going to rely on your answers because maths is not one point where we should be doing much discussion. We have already done the integral. You should be able to find the answer. If you can't do it, then you just need to do hard work. Okay, well done. So whether it's part 1, whether it's part 2, whether it's part 3, answer has to be -2. So in one of the options, you will find -2. In maybe one of the options, you will find +2. In maybe the third option, you will find something else. So you can just take the option with -2, and you have done a multiple choice question in a JEE advanced paper and probably scored +4. Okay, shall we move again? Okay, now the question is like this. Question number 2. I'll make the same question. Point A, 1, 1. Let me make it differently. Don't want you to get trapped in maths. Just want you to understand the concept in physics. So I'll make the question like this. Okay, this is my origin. This is the point A, whose coordinates are 1, 2. So obviously this has to be 1 and this has to be 2. I don't want to make a complicated problem where you get trapped in maths. Okay, now again I'm going to do the same thing. I'm going to move an object or a particle in 3 different paths. This is path number 1. This is path number 2. And then there would be a straight path. That would be my path number 3. Oops. That would be my path number 3. Now, the force that we are talking about here is F vector is 3yj hat. Okay, let me put some I also. This might make the question a bit difficult, but if you can understand this, you would be able to do any question that comes in this category. 2yi hat 3yi hat minus 2j hat. I made a very complicated force. I could have made it easier as well. Doesn't matter. Now, again, I ask the same questions. I do it in 3 different parts. Work done. Again, I have 5 options. Work done in part 1 is this, work done in part 2 is this, work done in part 3 is this, work done in all parts is same, work done in all parts are different. 5 options. What is the answer for this one? And again, what is the way? How are you going to start this question? What is the first thing that you must do? And again, this question will never, ever, ever come in JEE Mains. Never. Never come in JEE Mains. What is the first thing that you will do? Anyone? What is the first step of solving this question? Can anyone tell me the answer? No one knows what is the first step of solving this question? Okay, the first step would be to find out whether the given force is conservative or non-conservative. What is the answer? Is this force conservative or is this force non-conservative? You'll have to do a check. And here there is no term of K. Z is missing. So you don't have to do the check of Z. So instead of 3 checks, you only have to do 1 check. And that check is to find out the derivative of fx with respect to y and fy with respect to x. That is the check we are going to do. Del of fx with respect to y, because z is absent, so don't have to do any check of z. What is del of fx with respect to y? Anyone?
Three, sir.
Well done. It has to be 3. It is 3. No questions asked, no answers given, no reasons given. Second thing that we do, del of fy. Oops, not fy. I've written fy, but I've said fy, but written y. Del of fy with respect to del of x. What is the answer to this one? Oops, wrong color. What is the answer for this one?
0, sir.
0, 0. So now we have a situation where one thing is 3, the other is 0. That gives us the first answer, whether this force is conservative or not. And we now have the answer that this force is non-conservative. So out of the 5 options that you see, option number 1 says work done by force 1. Option number 2 says work done by force 2. Option number 3 says work done by force 3. Option number 4 says work done by forces in all parts is 0. Option number 5 says work done by forces in different parts are different. What are the correct options now? About these 3 we don't know, but we know about these 2. This option, work done by force in all parts is 0, is wrong, so you take it out. Work done by force in different parts would be different. Option number 5 is correct and option number 4 is wrong. Do we get this? Yes or no? Now you have to find out the work done in different parts. And that is a task for you to do it. Think how you are going to do it. Remember, I've given you the formula. This formula is valid everywhere. I told you that. But again, if the force is path dependent, you'll have to look for the path. You cannot straight away apply the integral. Sir, straight away apply kar denge integral. Nah, you cannot straight away apply the integral. You can only straight away apply the integral when you are sure that the force is conservative. You don't have to think about the path. This formula is always valid. It's never it is an invalid. It is always valid. But now you have to think about path. And that is the task for you. How would you think about it? It's not rocket science. It's even not physics. It's very simple, common sense. That will tell you how to look for the paths. Paths are already given to you. Remember, in such a question, path will always be given to you. If path is not given to you, this question is unsolvable because no one in the universe can solve it. Unless and until paths are given, because this is work done by a non-conservative force. So you have to know the path. Path number 1, path number 2, path number 3 is for your homework. I know you will not do it, but still, at least try. And trials are important. Answers are not. I'm not worried about the answers. I'll find a question to what answers you are giving me, and I tell you, if this is the question, then your answer is correct. As someone told me, the derivative of t with respect to x is 2x. I told you, your answer is correct, but my question was wrong. Your answers are never wrong. I'm not concerned about the answers. So I hope you have enjoyed the class, and maybe in the next class we'll wind this thing up. Again, it is specifically meant for JEE Advanced. It can never, ever, ever, ever come in JEE Main. JEE Mains, it would be a conservative force. You just have to put the formula, get the answer, stay happy, and you should always remain happy. Take care. Have a good day. If you have any doubts, ask me. Bye bye.